right, so the next topic or set of topics here, essentially things that we've already seen in action, such as read Boolean, read double, and so forth, and even read UTF. We saw that UTF is very successful reading the previously written string, but you can also skip bytes. So, for instance, if you know the output format, you can easily say skip bytes, and that simply advances the input from the file by skipping certain amount of bytes and giving you a chance to move forward and read from a position which is way X number of bytes away from the beginning. But remember, when we process the binary files, usually everything is counted in bytes. So generally speaking, we need to be aware of how big is an integer, how big is a double, how big is a character. Of course, Java explicitly specifies the actual sizes of the primitive data types. In C++, you have the size of operator, which can measure and give you the sizes of your objects in bytes as well. Okay, so data input stream methods, you can also find out whether you already hit the end of file or if there's more available bytes. Perhaps we can try available. Okay, we can say in our sample right here that we've tried, we can say that before we read everything, right, before we proceed to read everything, we can say system.out.print print another line where we say available, right, and we can just print in.available, which returns available bytes. So let's just say available, okay, and we'll print what's available. And then at the end of our, supposedly at the very end of our processing, right at the bottom of this, or perhaps before we close, right there, right, we say available and print what's left available after the last attempt to read something from the file, as far as we know our format. So let's just try this. So it says here available 31 bytes, and then it says available 0 bytes. So interestingly enough, if I if I just go here and look at the properties of my file, right there it says that the size of my file is 31 bytes. Okay, so on this system, yes indeed, it stored 31 bytes, but of course on disk it takes a whopping 4 kilobytes to store, because the 4 kilobytes is obviously the cluster size of the unit of storage on my file system, and so to store 31 bytes of something, I need to waste 4 kilobytes of disk space, and that's remaining part of it is what's called slack, the file system slack, that unfortunately is the byproduct of the file system being using the block device, right? So the logical size of the file is 31 bytes, but the physical size on disk is 4 kilobytes. But even this could be a lie, because here's on NTFS it all can be actually fitting in the master file table that it contains, and it's all kind of interesting information that you read here, but it may not be always true. But anyway, 31 bytes looks pretty good to begin with, because so just remember that you could occasionally check the size of available data by simply saying how much is still left available. So if you're expecting to read an integer, you can check if there's more than 4 bytes still available, then probably it's okay for you to try reading an integer, as long as you understand the format of your files. All right, so this was interesting. So just another example. We've tried all of this already. So here's another read UTF and read double, which is all familiar to us because we already have done that in our example. So writing binary strings, once again, I think I mixed those two things up on this slide. This should say write characters, and this should say write UTF, because it's write UTF that stores string in this universal text format UTF, and the first 2 bytes contain the length of the string, and that is followed by each character stored in a single byte. So interestingly enough, it's only 2 bytes, so it's like a short integer specifying the size of the string, which can only go to like 64 kilobyte in size. So your string cannot be really more than 64 kilobytes in size, which you store in this universal text format, because there's only 16 bits to accommodate its length in that storage. So just an observation. All right, so we're pretty much nearing the end of this presentation, and the rest of it is just samples. And there's actually another part of the library right here, creating a writable file with Files.newOutputStream, which can also be used for writing binary data. And the new output stream is just a method which is present in the Files utility class. A new output stream will require the path and standard open option, which is kind of interesting set of options. And guess what? It returns the output stream object, which is the same thing. You can use it to write your booleans, integers, and so forth. So, but this gives us a choice, more choices in terms of the modes in which we can open the files. And those modes include append, create. Append and create are those 2 major options that we basically have seen already. So append, if the file is opened for write, for the write access, then everything will be written at the end of the file. So then we create, always create new file, and also create it if it doesn't exist. Create new creates new file, but will fail if the file already exists. So with the prior version of what we did was it wouldn't be possible to specify those types of conditions. Here we can. Delete on close. Delete on close is simply close the file and it automatically is going to delete it. So this is useful when you use a temporary file. When you create a temporary file to say store some data temporarily, maybe sort data in the file and something like that, and do that. Desync, data synchronization, requires that every update on the file's content be written synchronously to the underlying storage device. I wouldn't recommend doing this because this essentially kills all the buffering. But this would be something that you would want to do if you were to program a small database. You want to synchronize. There's your variable to synchronize or mode to synchronize. Read only. Sparse, work with the sparse files. Sparse files are not available on all systems, but Unix systems do support sparse files. It's simply that files that can have gaps. Essentially, you specify that you want to store 100 bytes at the beginning of the file, then move on to 1,000 bytes down the road and write more information. In between, there is a gap. So the Unix operating system will support that and will not fail doing something like that. Other file systems may fail, so be careful regarding the sparse file mode. Another sync mode, which has to deal with the metadata. Truncate existing, it basically says if you open the file for write access, then you can basically request that its size be truncated to 0, and that's fine. Right, so let's see an example of these modes, kind of interesting example of these modes. So you need this import in your code, right? So I can basically try maybe switching over to using this new buffered output stream mode with these modes. So what I can do is let me see if I can modify what I have right now. First of all, I need to import, statically import these constants that represent the file opening modes. That's fine. Then, of course, instead of using DataOutputStream constructor, instead, if I wanted to incorporate any of these modes, what I need to do is, according to our sample right here, right, we need to essentially do something like this. I'll start copying from here, right? So this would be an alternative to what I'm doing right here. So let's see, if I wanted to say out, the new way of doing things would be out equals new buffered output streams. Files also needs to be imported, so I'll import the files. New output stream file here would be perhaps my directory string. I hope it can take that. All right. No, it has to be converted to the path. So I'll just say path equals path file path, right? And I can say equals paths get path for the directory stream, right? Is that, yeah? So I can also do this early on, somewhere before I begin all of this, right? So I can use file path, and I can pass this file path to my new output stream. All right, there, so to make it happy. So if I wanted to create the file, then I could combine this mode, like this with perhaps a request to, on the previous slide, we had this other option available, which was, for example, a truncate existing, right? So I can combine these options right there, and in my code, I can say truncate existing. Is this the way you can, or do you have to use the plus sign? Oh, I'm not sure what that is. Let's find out.